I feel terrible. I live and breathe by this calendar. I mean, I don't do anything without looking at this. And for some reason, that seemed like it was 6:30. I was just remembering it to be 6:30. So
I think it was because it was supposed to be 6:30 yesterday.
probably. Oh, that's probably why I got confused. Yeah. Yeah, I apologize. Okay. I don't usually do that.
No problem.
All right. Let's see. We left off with number 3 of arithmetic means.
Mm-hmm.
Let's pick up with number 4. Let me turn off some of this stuff. It'll help my computer. Okay. Can you make that out? What's the average of the positive integers from 1 to 100 inclusive?
Okay. You take the difference between the two divided by the number. So that would be 99, right?
Well, I'm not sure how you're doing it. You're trying to apply that formula of the sum of consecutive integers?
Yeah.
Well, I think that would be the first term plus the last term.
So it would be 101 divided by 2?
Times 50.
Why would it be times 50?
Well, let me show you the way I would figure this out. There is a formula for how you sum up consecutive numbers, and it's basically this.
I just don't know where you got the 50 from.
Well, let's look at it a different way. What's the average between 1, 2, and 3?
2.
What's the average between 1, 2, 3, and 4?
2.5.
So 1 through 100, what's the average going to be?
I want to say 50.
50.5 because there's an even number of terms. In other words, here we had an odd number of terms, so the average was the same as the middle. Here we had an even number of terms, so the average had to be halfway in those two middle. So this average has to be halfway between 50 and 51. That's the way I would do this problem.
Well, so for example, you know what the formula I said before?
Mm-hmm.
I just found it, and it's just the sum of all the integers divided by 2. And so that would be 101 divided by 2, and that's 50.5. So it's basically the same.
Okay, so it's the first integer plus the last integer divided by 2.
Yeah.
Okay. Yeah, let's look at this one. We have 10a plus 10b equals 35. What is the average of a and b?
So A and B together, or just A and B?
Yeah, they basically mean what is a plus b divided by 2.
Okay, well then you would have to say, you would have to remove the 10.
Okay. Let's factor the 10 out. So now we have 10 times a plus b equals 35.
And then you say a plus b equals 35 divided by 10.
Okay.
So A plus B equal 3.5.
Right, but what they want is A plus B divided by 2, which is the average of A and B.
Yeah.
So it would be 3.5 divided by 2, or 35 divided by 20. What is that, 1 3/4?
Yeah, I think so.
Okay. So a lot of the difficulty in these things is figuring out how to translate their question into an expression. In other words, when they say, what is the average of A and B, we need to know that that means this. And I noticed that this test is unique in that respect. I do a lot of SAT and ACT tutoring, and they don't use that principle. It's not as confusing figuring out what they want. Okay. Now let's write this out. X plus y equals 6. I'm going to write it a little different because this is the way I would write it if I was planning on trying elimination to answer this. By elimination, you know what I mean? In other words, by solving simultaneous equations. We have 3 equations and 3 unknowns. So with enough time, we could solve for x, y, and z. And what do they want? They want x plus y plus z divided by 3. That's the number they're looking for. Now, I wrote it this way to line up the x's, to line up the y's, and to line up the z's, not because I knew anything. I just thought that that might give me an extra clue. How can I generate this without going through all of the trouble to solve this? Because as you probably know, it's quite difficult to solve 3 equations and 3 unknowns. There's a lot of legwork there. That's probably a good 2 minutes to do that.
Well, can you subtract them? Or
think add. Let's add all 3 equations. Notice what happens.
2x plus 2y plus 2c is equal to 22.
So now tell me what x plus y plus z divided by 3 is.
Well, first you have to divide by 22, or by 2.
Okay. So x plus y plus z equals 11. If I divide every term by 2.
So it's 11 over 3.
Okay. The average of 5, 6, 7, and W is 8. What's the value of W? What equation can I write from that first sentence? The average of 5, 6, 7, and W is 8.
It's 5 plus 6 plus 7 plus W divided by 4.
Now solve that equation for W.
So it would be why do you get 32?
Multiplied both sides by 4,
Oh, okay.
and then
So you multiply 32 by
subtracted 18.
4. Oh, because 4. Oh, 8 times 4 is 32. Those are 18, so it's 14.
Right. Okay. Now, there is another way we could do this problem that might actually be easier, and that's to back solve it. Obviously, 8 is not going to produce an average of 8, right? So we can rule that one out. Let's try 12. If we start with the second, in fact, we should start with the second lowest. So if we start with 12, we have 18 plus 12. 30 divided by 4 is not 8, and then we know we need a bigger number. So next, let's try 16. And now we have 18 plus 16 is 34 divided by 4, which is more than 8. So now we know we need a smaller number, and we know 14 is the answer. I personally think that this is the easier way to solve it. This is the algebraic solution. And I rarely say that. I'm a huge fan of back solving. But when it's this simple of an equation, probably algebraic is easier. Let me think about this for a moment. Yeah, let's do this one because this requires you to know the sum of the angles in a pentagon.
It's 545.
So it's 540.
Oh, I thought it was 45.
No?
But it's
They kind of go, notice that a triangle is 180. A rectangle is 360. A pentagon is 540. In other words, each one is 180 more than the other. And the formula is actually the number of sides minus 2 times 180. So this gives you the sum of the interior angles.
Don't you have to divide by something too?
No? Well, in this problem we do, because they're asking for the average. But in terms of the sum of the interior angles, this formula here gives it to you. If I said, what's the sum of a 22-sided figure, it would be 20 times 180, or 3,600 degrees in a 22-sided figure. Okay, so if the sum in this 5-sided figure is 540, what's the average angle?
108.
Uh-huh. Okay, what do we got? A plus B equals 3 times C plus D. Which of the following is the average of A, B, C, and D? So what are we looking for? Give me the expression.
A plus B plus C plus D is divided by 4.
Okay, so that's what we're in search of.
Yeah, you need to divide.
We notice all the answers have a C and a D in it. Okay, so go ahead and divide both sides by 3. Now what?
Then you multiply both sides with 3.
Well, let's go back up into this expression, which is what we're looking for.
Then you have to move the stuff to the other side, but then it's divided. You're not, you know.
Well, actually, I didn't even need to do this step, particularly since all the answers are in terms of C and D. By doing this step, I'm going to put everything in terms of A and B, and that won't work. So let's step back a moment. Here's what we're trying to find, and it needs to be a function of C and D. So how about if we just take this part right here and substitute this? So we would have 3 times C plus D instead of A plus B, plus C plus D over 4. So there's our answer once we simplify. Simplify that. What do we got?
You have 3C plus 3D, right?
Uh-huh.
So you have 4C plus 4D. Divided by 4, you have C plus D.
E. Beautiful. Notice, let's just go back a moment. Notice why I substituted for A plus B instead of substituting for C plus D. In other words, I could have done it this way. I could have done A plus B, and then we knew that C plus D was equal to A plus B divided by 3. So I could say, okay, but we're going to get an answer that's in all A's and B's. And none of our answers are in A's and B's. So we have to substitute for A and B instead of substituting for C and D.
Yep.
All right. And please remind me to go to 7:15. I don't want to forget. Assuming you can. Either that or I'll only charge you for 3/4 of an hour. Okay, number 10. Lines L and M, the two horizontal looking lines that you see there, are not parallel. If A represents the average of the degree measures of all 8 angles, which of the following is true?
Okay, it's not E.
Okay.
That
What is the average of all 8?
Well, isn't it 4 times 80 or 180?
Yeah, because each pair, in other words, if I laid it out like this, I know that A plus B is 180. I know that D plus C is 180. I know the other one is, and I know this one is. So it's this divided by 8, which has got to be 90. Why did I know that? Because if I divided it by 4, it would be 180. Since I'm dividing it by 8, it's got to be half of 180, which is 90. That's 720 divided by 8, so that's 90. So capital A equals 90. Whether these two lines are parallel or not, because those two are supplementary, so are those, so are those, so are those. So let's see what else. Which of the following is true? A equals 90. We're done. Why did they tell us those two lines weren't parallel? It had nothing to do with anything.
It's probably to, like, mess you up.
It is. Absolutely. It's to throw you off. It's not the first question I've seen where they throw in irrelevant information.
What is the average of 210 and 220?
That's the way that would be read as 2 to the 10th power and 2 to the 20th power.
Okay.
So let's write that out.
So it would be 2 to the 10th power plus 2 to the 20th power divided by 30?
2. There's only two
Why
numbers
do we divide by 2?
because they're just two numbers. If I said,
Oh,
what's the average of 4 and 11, I would add 4 and 11 and divide by 2.
yeah.
Okay. Now we have to pull a little algebra magic out.
I'm not sure.
Okay. I can split this into two fractions. I can split it into that, and I can split it into that, and add them together. Right? Okay. This one becomes 2 to the 9th, because it's 2 to the 10th divided by 2 to the 1st.
Plus 2 to the 19th.
And that doesn't appear to help, except if we look at the answers, that's the way they're giving the answers. So it would be C. Now, it's very important that you don't make the following mistake. A plus B over C is equal to A over C plus B over C. However, A over B plus C is not equal to A over B plus A over C. I can split this up into two fractions because I have a single entity in my denominator. I cannot split this up into two fractions because I have a double binary binomial term in the denominator. Okay?
Yeah.
Okay. I'm going to go ahead and write these numbers in order because I know that's what you would do as your first step. Whoops. I didn't see the 90.
Let n be the median and n the mode of the following set of numbers. What is the average of m and n? Well, the mode is 70.
It's the median.
There's an equal set of numbers, so isn't it 70 plus 40 divided by 2?
55 and a half. Mm-hmm. Oh, excuse me. 55. Where did I get the half?
Sorry, I was like, I don't get it.
Well, I had already jumped to the answer and couldn't figure out why I was wrong. Because halfway between 40 and 70 is 55. Yeah. I think I must have taken a peek at the answers when I was seeing that. I saw that 0.5 and it leaked in. So what's the average of these two numbers?
62 and a half.
Right. And I can go through the process of adding them and dividing by 2, but I can also just figure out what is the middle number between two numbers. If I'm looking for the average of two numbers, is all I have to do is take the middle number. Of course, in that problem, that doesn't necessarily make it easier. It's almost easier to add them together and divide by 2. All right, so I think we're done with averages. So we have polynomials, equalities and inequalities, and word problems are the only other subsets that we have to cover. So 3 more of these subsections and we will have covered all of the basic math, all of the algebra, geometry, and number theory.
Yeah, I'm not sure we'll make it though, because I have to take the test in 2 days. But
Okay. Well,
that's okay, because I mean, if I don't make it this time, I'm going to take it again. So.
all right.
What is the value of a squared minus b squared divided by a minus b when a is 117 and b is 118? Can't you divide first before you do that?
Well, by divide, yeah, what do you mean?
Because if you say a into a squared, wouldn't that
That's
be
a tough way to divide. Doing long division is tough. Think of factoring the top and then dividing.
well,
What's this
so
called?
a squared is b squared minus 2ab.
Actually, a squared minus b squared is the difference of squares. So it's always a minus b times a plus b.
A plus b.
That's a key thing to memorize. You'll run into a lot of difference of square problems. Okay? So now we have a minus b over a plus b divided by a minus b. Well, this cancels with both of those, and I'm left with a plus b. So my answer has to be 118 plus 117.
235.
Uh-huh. But doing long division would have been incredibly difficult if I would have tried to do it this way. They don't intend for you to do it this way either. I'm not even sure I know how to do that division. But it comes out to a plus b.
Uh-huh.
Now let me make this just a little smaller so that I can... hold on. I'm all screwed up here. Got to use my cursor to make this smaller. All right. If a squared minus b squared equals 21 and a squared plus b squared equals 29, what's the following could be the value of ab?
Could be the value of a times b.
Right, the value of the product ab. Let's go back to those 3 things that I suggested would be extremely useful to memorize. The one we just covered.
Yeah.
And these
I know
2.
those.
Okay, what are these? Let's list these out and it'll show you how to do this problem. What is a plus b squared?
It's a squared plus b squared plus 2ab.
Right. I usually put that in the middle. But now, we know what a squared plus b squared is. It's 29.
Uh-huh.
And a squared minus b squared
Oh, you're asking me what it is?
No, I'm trying to figure out how to do it. I thought this was going to give us the solution by looking at it like this, and I still think it will. All right, let's write it out as two equations. This might be the better way to go. Let's add these two equations. What do we get?
2a squared
Right?
a equals 5, yeah?
Okay. This was not the way to go. That would have gotten me nowhere, I don't think. The way to go is to definitely deal with it as two equations and two unknowns. So a is 5, and if I subtract the two equations instead of adding them, I get 2b squared equals 8, b squared equals 4, b equals 2. So I solve for both variables, and the value of a times b is 10.
How does that, because it has minus b in one of them, so how can it be 2b squared?
Because if I subtract the second equation from the first one, you take b squared minus a minus b squared, and you get 2b squared.
How do you get 2b squared? I don't understand that.
If I do a b squared minus a negative b squared,
okay, yeah, okay, I get it.
okay. Now, this is a little bit of a tricky problem. I didn't quite do it right because I didn't allow for the plus or minus. B actually came out to be plus or minus 2, and A actually came out to be plus or minus 5. And that's going to be critical here because they say indicate all possible values of A times B. Well, so that could be plus or minus 10. So it's A and C. You see why I have to allow for the plus or minus? When I solved for a squared, I ended up with a squared equals 25, and the solution of that is a equals plus or minus 5. Just like the solution for b is b equals plus or minus 2. Okay? This is a tricky question. I would have sworn anything when I looked at this question that it was going to involve knowing what a plus b quantity squared was. Because usually they want you to know that. Have I given you the famous question that is perfect for the GMAT? This actually is from a GMAT test. I think I gave it to you. What is this? What's that equal to?
1.
Yeah. And you certainly don't do it by going through the math and squaring 100 and multiplying that and subtracting. That would take forever. But as long as we recognize this is a minus b, with a being 100 and b being 99, as long as we recognize it as that, a minus b squared, or 100 minus 99 squared. All right. What is the average of, I'll write it out because I don't know if you can read that, 2x minus 3 in parentheses plus, wow, 3x squared minus 2x minus 3 plus 30 minus 4x, what the heck is that, squared?
But there's no plus signs, there's commas in between.
Right. I put the plus signs in there because they're asking us about the arithmetic mean. So what do we have to do to these four things?
You need to multiply or like reduce them.
Well, you add them together, divide by 4. That's how we get the arithmetic mean.
Why divided by 4, not by 3?
Because there's 4. Oh, you're right. There are 3 terms. I'm sorry. I thought there were 4 terms. I didn't see. I was thinking there was a comma after the x squared. Okay. And if we look at our answers, we can see that some of the answers have x in them. So there's no way everything needs to cancel. How many total x squareds do we have?
You have x squared plus 3x squared, that's 4x squared, minus 4x squared, that's x squared.
So they all cancel. They cancel to 0. How many x's do we have?
2x minus, that's 0.
How many numbers do we have?
Minus 3 plus minus 3 is 0, so you have 30 divided
Actually,
by
that's
3.
minus 6. Minus 3 plus a minus 3 is a minus 6.
Yeah, 6 plus 30
That's 24.
divided
By 3
equals
is our answer.
Do you want to go over to the test because it's 6 minutes till?
Yeah, we're going to go to 7:15 if you want at least.
Yeah, I need to
Okay.
leave here at 7:10 though, so
Okay.
yeah, but that's fine.
Let's see. Test 1, number 6 is where we left off. So where is test 1? Test 1 is up here. We want number 7, or we want the next data sufficiency. Well, let's check and see if 7 is one. It's not. So let's go to this page. First data sufficiency on this is 14. Here, let me blow it up a little bit. Okay. So we have 4x squared minus 4x equals negative 1. It's proposition number 1. Proposition number 2. Can't talk and chew gum at the same time.
Well, you need x by itself.
Well, we definitely need to solve for x.
Well,
A quadratic usually gives you how many values of x?
2.
Okay, so we might think that that quadratic cannot give you x and that quadratic cannot give you x. But if there's a common solution between them, together we might be able to solve for it. However, there is one other kind of quadratic that gives you 2 solutions, but they're both the same. So we have to consider that also. So how do we solve these? Let's try to solve this first one here. How do you solve a quadratic?
How do you solve?
How do you solve a quadratic? These are both quadratic equations, and there's only one way I know of to solve a quadratic.
How about you move minus 1 over to the other side so it's plus 1 and then you factor it?
Okay, that's what I was looking for. Now,
So it's x, or 2x, sorry.
it's not necessarily 2x. It could be 4x and x, but let's try the simplest one first.
And then 4 and 1.
Not 4 and 1, 1 and 1. Remember, we're looking for factors of 1. In other words, these last two numbers have to multiply together. What's that?
They get in the middle then.
Well, those two middle equal minus 2x. These two middles are another minus 2x, minus 4x.
Yeah.
So, can we determine the value of x?
Yes.
Yes. Both of these yield the same value. X equals 1/2 or x equals 1/2. So this quadratic alone is enough to answer the value of x. Now let's check the other one out. And right off the get-go, we know that there is no way that that can yield the same kind of answer. The other one, in other words, you have to end up with two things that are exactly the same for you to come up with an exact value for x. This is going to have factors at best 5 and 1.
So the answer is A.
Right, A alone. Oh, I don't even have the answer key on these, but we don't need it. Okay, let me go to the next page. Let's look at 16. These are always, I find these particularly hard, these kind of data sufficiencies. I much prefer the data sufficiencies that have math equations and real short stems.
Yeah. A 30-ounce pitcher is currently filled to exactly half its capacity with a lemonade mixture consisting of equal amounts of 2 lemonade brands A and B. If the pitcher is then filled to capacity to conform to a certain recipe, how many ounces of each lemonade brand must be added to fill the pitcher? Well, one says the recipe calls for a mixture that includes 60% brand A. So you can't answer it with 1 because you know nothing about B.
Hold on. Well, we know that here's our pitcher, 30 ounces. And we know that it's half filled and half filled with each. So we know there's 7.5 of A and 7.5 of B to start with. So the recipe calls for a mixture that includes 60% A. So when I fill this whole thing up, I need 60% of it to be A. Well, what's 60% of 30 ounces? That's 18 ounces. How many ounces of each must be added to the pitcher? Well, I'm going to add 10.5 ounces of A and 4.5 ounces of B.
So A is fine.
So one answers it. 2. When filled to capacity, the pitcher contains 12 ounces of B. Well,
so that would be added 4.5, right?
Right. That tells us the same thing.
Yeah, because you have, so then you have 12, you know that can be, so you know that then A is 18.
Right.
Well, then,
so I'd have to fill up the rest of it with A. So I would know how much of each I would have to add. So this is either one alone. I'm looking. Boy, they put these few and far between on this one. It doesn't feel like they're even 25% of the questions. Here we go. These are the kind I like. I've never been confused by one of these. I shouldn't say that. Now I will be on this one. But some of those word problems, those can be mind-bending.
If A and B is not 0, is C over A larger than C over B?
And they're not 0 because obviously we can't divide by 0.
So A is larger than B.
How about let's do an easy one first?
Well, C is not equal to 0. Well, you can't solve it like that because you don't know what's on top.
Obviously. And that's the only reason I saw that it was the easier one. Let's get that out of the way.
And, okay, number 2, A is larger than B. Well, I want to say yes because let's just say that it was 1/4 and the other one was 1/2, then A would be larger than B, but it wouldn't be larger than CB.
Okay? Okay. So what you're saying is that with number 2, we can answer this question even though the answer is no. C over A is not greater than C over B, but we can answer it with this information.
I mean, I'm just wondering if there's any where you can find.
Well, that's what I'm looking for. This almost seems too easy. What about negative numbers here? If A is positive and B is negative,
But then that would say no, you can't solve it.
Exactly. So we may not be able to solve it with this. Let's try a situation. If I make A 2 and B negative 1, then is C over 2 greater than C over negative 1 for sure? But when I had A as 2 and B is positive 1, it's not.
Exactly.
So it does matter what numbers we pick. And it matters whether A and B are positive or negative. And nothing up here says they're both positive. If they said they were both positive, this would be a different answer. Okay, so no to number 2. Now the question is, do both combined help? Knowing that C is not 0,
so I guess
I just discovered something. Wow, I love this problem. One can answer it all by itself. If C is 0, oh no, excuse me. I was thinking it said C was 0, in which case you can answer this. If C is not 0, you cannot answer it from that. No, you cannot answer it from that, and you can't answer them from both of them because of the positive and negative part of it. And the only way I need to prove that to myself is by coming up with 2 situations like I did, where A was greater than B in one case, and this was smaller than this. But then in the other case where this was positive and that was negative, this came up bigger than this. As long as I come up with 2 answers, there's no way to tell.
Well, can they work together?
Well, that's what we were looking at. I don't think so.
Well, what I don't understand is that, so in number 2, I guess C could have been negative as well.
Right, but I don't think that matters. In other words, if C is negative as well, C over A would still be greater than C over B because we would have a, no it wouldn't, would it? It would be less if C was negative. In other words, it would be consistent with positive values for A and B if C were negative. But you can't guarantee that C is negative. C can certainly be positive. So if C is positive or negative, then this alone does not answer that question.
Yeah.
Although I do wish I had the answer key on that one. Because they can be tricky. These data sufficiencies can be extremely tricky. The price of a candy bar is doubled. By what percent will sales of the candy bar decrease? Well,
Each candy bar now costs 60 cents. You don't know anything about that. For every 10-cent increase in price, the sale will decrease by 5%. But you don't know how many, if it's been doubled, that would you, I mean, can you say that that's 50 cents because it's, like...
no, you're right. It matters what it starts at. In other words, if the candy bar was currently $1 and it was doubled, that would be to $2, which would represent 10-cent increases.
Mm-hmm.
But if the candy bar started out at $5 and went to $10, that would actually represent 50 10-cent increases.
Mm-hmm.
So one alone is a no for sure.
Yeah. So together, I guess you can, because you know that it now costs 60 cents. And that's doubled, so it cost 30 cents before.
Right.
And so it's been, you've put 33 times 10 cents in there.
Exactly.
So it's 3 times 5%, which is 15%.
Yep. But I think the important thing is not to do it.
Yeah, so the
In
answer
other words, when we were analyzing 1 and 2 alone, we did enough math to realize that if we knew what the cost of the candy bar either was in the beginning or now, that's all the information we need.
Uh-huh. Okay. Well, I unfortunately...
You got to go 7:10. Okay. Well, Cecilia, very good luck on your test tomorrow. And
well, it's on Thursday, so maybe
it's on Thursday.
I'm gonna book another time. But thank you.
You're welcome. And
But
good luck to you.
Thank
I hope
you.
I'm not talking to you after that, because I hope you do so
Well,
good that you won't need any more tutoring. But if you
that would
do,
be great. But you know what? I'm kind of at the point where I'm like, you never know. So
that's right. You don't
But
know.
like last time I got 23 data sufficiency questions out of 37.
That's not that bad. That's actually
Really,
pretty
I was
good.
what?
That's pretty good. But that doesn't say a lot in itself, because they get harder depending on how you're doing. In other
Yeah, but
words,
like
you're not going to get the same 37
surprised.
questions.
I just thought it was hard. Like I just thought it was weird. There were so many of them.
Yeah.
Because like they normally say that it's about like 15, close to.
Uh-huh.
I had 23.
Wow.
So we'll see.
Okay. Well.
But thank you so much. I'll talk to you maybe tomorrow.
Okay, Cecilia. Good night. Bye-bye.